Hey everyone, welcome back to Unit 4, Day 2 Notes. Today we're going to be discussing slope by counting and by formula. So to start, we're going to talk about slope. Slope is how steep a line is. And in more mathematical sense, it is our change in y, which is our movement up and down on a graph, over our change in x, which is our left and right movement on a graph. So that's how we find slope. Slope is represented by the letter m. Okay. So to go a little bit further, there are a few ways we can determine slope of a line. One of these ways is by identifying any 2 points on a graph. So we just need to pick 2 points on the graph and counting the change in y over the change in x. And once again, we call that change in y, we call it the rise on the graph. If we are going up, that's a positive movement. If we are going down, that's a negative movement. Over the change in x, which we call our run. And again, a movement to the left is negative, and a movement to the right is positive. So let's take a look at this first example here. We have a graphed line on our coordinate grid, and we are going to select any 2 points that we want. And we're looking for points that come in a nice cross section. So I see this one right here. This looks good to me. The line comes together at a nice cross section. We can see that coordinate is -3, -3. And then just to make things easier on us, I'm going to choose the origin, right? It goes right through the center of our graph, of our coordinate grid. And now I'm going to count, and we're going to look for our slope, our m, which again is the change in y, or the rise, over the change in x, which is our run. Okay, so now we go to our graph and we count. It does not matter which point we start at, we just need to count our rise. So I'm going to start from our coordinate -3, -3, and I'm counting our rise, which is going up 3. So if we are going up, that's a positive movement, and we went up 3, so our rise is 3. And now we're going to our run, which is how far to the left or right. In this case, we are going to the right, which is a positive movement. So we are going 3 to the right. So our slope is 3 over 3, which when simplified equals 1. Okay, so let's try some more examples here. All right, number 1, again, we have to find 2 coordinates that come in a nice cross section for us. And I see this one here, and this one here looks pretty good. These aren't the only 2 options. There are other options you could choose. They are just the ones that I selected. So for counting our rise and our run, for our slope, we can say, okay, we're going up 1, 2, 3, and we're going to the right 1, 2. So it's a rise of 3 and a run of 2. So our slope is 3 over 2. This we can't simplify, so we just leave it as is, and that is our slope. We don't want to turn into a mixed number because for slope we need a rise and a run, and giving us a mixed number will give us a whole number, which would not work when we are counting slope on a graph. Okay, number 2. I'm going to go ahead and pick 2 points. I notice this comes at a nice cross section for us, and this one here. The closer you can choose your points together, the less likely you're going to have to simplify because you're not going to have to find iterations between that. So I'm going to start again at the point on the left. We're looking for our slope, our rise over our run. So the point on the left, we go down 1, 2, 3. Going down is a negative movement. So that's -3 for our rise. And our run to the right 1, so that's +1. So our slope is -3. Okay, we have a different looking one here for number 3. So we need to, again, pick 2 points. So I'm going to pick this one and this one. Again, there are more options than what I've chosen here. And now take note, in this one, this example is a little bit different. This is a vertical line. So let's see what happens. If we count, I'm going to count from the bottom one. So I have a rise of 1, 2, 3. I'm going up 3. But notice how I'm not going over any. I'm not moving to the right or left. So our movement over, or our run, is 0. Now, 0 on the denominator, you cannot divide by 0. So that is one indication, if you forget, that this is an undefined slope. So that is the slope. It's undefined. It is not 0. You cannot divide by 0. So if you see a vertical line, your slope is 0. And if you forget that and you go through and you do the math and you see you have 0 in the denominator, type that into your calculator, you're going to get an error. So that is an indication to you, something's up, something's different. So this is an undefined slope. Okay, let's try number 4. So again, pick 2 coordinates that come in a nice cross section. Bam, choosing that one. And bam, this one. I am going to start from the point on the left. And that movement is down 1. So that is -1. And now I'm counting to the right. 1, 2, 3, 4. Right is positive. And there we go. We cannot simplify 1/4, so it is -1/4. Okay, we have another different one. If we take note, the other one going up and down is a horizontal or a vertical line. Going left to right like this one is horizontal. So let's see what happens with a horizontal line. Pick any 2 points, choosing these. If I start with the one on the left, I'm going to go ahead and count. Notice how our rise is 0. We go up 0, but we go to the right 1, 2, 3. So 0 over 3. You can do 0 divided by a number, as long as it's not 0 divided by 0. And that equals 0. So a horizontal line will always have a slope of 0. So if you remember that, if you see a horizontal line, slope is automatically 0. If you do not remember that, you can still go ahead and try and find the rise over run. And when you calculate it, you'll get 0. Okay, and number 6. So, again, any 2 points. I'm going to pick some that are a little bit farther apart this time, just so we can see what happens. So, I'm going to be counting up 1, 2, 3, 4. So that is a rise of 4 and a run of 1, 2. 2 to the right is +2. You notice I did not pick points that were super close together, so we do have some simplifying to do. We can go ahead and divide by 2. Oops. And we get 2 over 1. Now, if you noticed, 4 divided by 2 equals 2. If not, you can get to this point, and you notice 2 divided by 1 gives a slope of +2. Okay, let's move on to the next page. So the second way that we can determine slope, first was by counting on the graph. The second way now is by using a formula. Now the formula does the same thing, except when we don't have a picture of a graph, we can still figure out the slope. Again, slope is represented by the letter M. We'll be using that a lot in the future. And the top, remember, is our change in y. And mathematically, this is represented by subtracting y2 minus y1. And then over our change in x, which will follow the same pattern, x2 minus x1. So the 2's and the 1's are there to just help us determine, okay, and organize our information. To help us determine what's our coordinate 1 and what's our coordinate 2. So let's jot that down. So we have 2 coordinates that we need to find the slope, just like we needed 2 points when counting. So coordinate number 1, you'll get your ordered pair, and you'll label those x1 and y1. And then we have our coordinate number 2 that you'll label with x2 and y2. So it's just to denote, hey, this x value is coming from our first ordered pair, this y value is coming from our first ordered pair. And then same thing with the second coordinate. The other detail that we can notice after we get our answers, we can visualize and see and determine what the graph is possibly going to look like, at least a general outline. So if we get a positive slope, the graph should be going up to the right. If we get a negative slope, it will be going down to the right in some fashion. It might be steeper, might be a little bit flatter, but either way, positive from bottom left to top right, and if negative from top left down to the right. Okay, so we are also going to be identifying that moving forward. So let's try some examples. So use the formula to determine the slopes of the lines with the following coordinates. So notice every example we are given 2 coordinates because you need a minimum of 2 points to form a line. And when we do that, we should start off by labeling our x's and our y's. So it does not matter which point is our coordinate 1 and which one's our coordinate 2. We just need to decide and stick with that. So our formula, I'm going to jot it down here. Not for every problem, but at least while we're starting off, y2 minus y1, x2 minus x1. And once we label that as for our coordinates, all we have to do now is plug the information in. So we first need to identify our y2, which in this case is a 6, minus our y1, which is a 5. Then we have our x2, which is a 3, minus our x1, which is a 2. And now we just do the math. 6 minus 5 is 1. 3 minus 2 is also 1. When we simplify 1 over 1, we get a slope that equals 1. This is a positive slope, so if we were to visualize this, the graph should be going up to the right. All right, let's try number 2. x1, y1, x2, y2. Let's go ahead and plug it into our formula. So we get y2 minus y1 over x2 minus x1. And we do our math. Negative 4 minus 1 is negative 5. Negative 6 minus 4 is negative 10. Negative 5 over negative 10 simplifies to being positive 1 over 2. So our slope is positive, so it should be following that general format, up to the right. Our next example, number 3, x1, y1, x2, y2. Get into the habit of doing that. It makes solving this a lot easier because now all we have to do is plug the information in. So y2 is 0 minus, now be careful, we are subtracting a negative 10. If you recognize that we are subtracting a negative is the same thing as adding a positive. So you could write this as 0 plus 10. And then we have negative 4 minus 0. So we get 10 over negative 4, which then simplifies to negative 5 over 2. So our slope is negative 5 over 2. Okay. Oops. All right, so go ahead, take a few minutes here to try 4, 5, and 6. So pause the video now, try them out, and then go ahead and click play when you are ready to reveal those answers. Okay, welcome back. So take a look at these answers. For number 4, we have negative 6/7. So negative, our graph will be pointing down to the right. You cannot simplify negative 6/7, so it just stays as is. Number 5, we get negative 4/6, and that simplifies to negative 2/3. Again, a negative slope goes down to the right. And then our last one, number 6, we get 8 over 12, which simplifies to 2/3. And that is a positive 2/3, so this time it goes up to the right. Okay, let's move on to our last section here. We have some special situations. Just a quick reminder, when the slope of a line is 0, then the line is horizontal. So that's what we just discussed on the previous page when we were counting the slope on the graph. And then also, when the slope of the line is undefined, the line is vertical. So again, a little visual. Horizontal is just straight left to right, and vertical is straight up and down. All right, so go ahead and try these examples. 1, 2, and 3. Determine the slope of these given coordinates. When you're ready, come back and check your answers. See you in a few. Okay, welcome back. So this first example, we get 0 over 7, which simplifies to just 0. And any slope that is 0 is automatically a horizontal line. The second one, we get negative 6 over 0. And anytime we have 0 on the denominator, we cannot do that. That means we're dividing by 0. So this slope is undefined. It's vertical. And then the last one, number 3, we have m equals 1. Our slope is 1. It's positive, so it goes up to the right. One thing to take note of is, if you remember this, if our y values are the same, then we will get 0 on top or on the numerator every single time. And if we have our x values are the same, then we will go ahead and get 0 on bottom, because 3 minus 3 will equal 0. So just keep that in mind. All right, thank you all for stopping by. Peace out. Have a good day.